spinning objects. And what we have here is this direction. We have the concept of gravity. So this is the force of gravity going down, and in this direction here we have the concept of a centripetal force, and it's all tied together through the force of tension. So the first question is asking what's the actual distance. So the actual distance is the circumference, and so the distance is the circumference, which is equal to pi times diameter. So that's the first question here, pi times diameter. Now it's 50 revolutions, so it's times revolutions. And in this case it goes 50 revolutions. I'm not sure, I guess it goes different revolutions for each test question. Velocity of the block is always velocity equals distance over time. And the distance is going to be from this question here. And time is going to be 38 seconds in this case. I think they all might be 38 seconds, but that would be the big difference there. So this is meters, and then the velocity is meters per second. And then magnitude of centripetal force, this is Fc, that's measured in newtons. And once you have the velocity, then that's pretty easy. So this is Fc equals m of the spinning object times the velocity of the spinning object squared divided by the radius. And that's the mass of the spinning object, and the radius is always 0.5, making our diameter 1 meter. So that's the force right there. Now if the system is balanced, then as we see here, the centripetal force is going to be the same as the force of tension, which will then be the same as the force of gravity, because we're balancing this and we're keeping that bead steady. So this is in static equilibrium, which means it's not moving. It's spinning, but yet it's not moving with respect to up and down. So the magnitude of the force of tension, and the magnitude of the centripetal force, and the magnitude of the force of gravity should all be the same, due to this idea that they are the same. So, and of course those are all newtons. And then finally, the mass of this bag, the mass that is hanging down, the hanging mass, is going to be equal to the weight and the mass, and then g, and then of course on Earth g is 9.8 newtons per kilogram. So the mass of the bag is, you take the force, which is here, and then you simply divide it by gravity, and then that will give you your mass. And of course the mass is measured in kilograms. And that's how you get the work through the whole question here.